Okay, I think I'm going to, instead of uploading these as one big video, um, upload them in parts whenever I just take a break, because I don't even know how I spent an hour and a half on that. Anyway, the thing I'm trying to get across here with this is that yes, this section right here, the B, is what you're. It's not always the case, but in this, it is what you're putting on the left-hand side to get the knot right through transp. Does that make sense? So, like, technically speaking, it is like, let me make sure it's on up. You know what? Whatever. I have to actually type something to get it to work. But, like, it actually is, let me move this out a bit. Like, that actually is what, is going on here, right? And obviously the rule of transformation there is transp. Okay, if this will play along, holy crap. My ear's screwing up again. You have no idea how hard it was to fight off the temptation of cheese puffs. I had more cheese puffs, and I had to very, very, very difficultly struggle. That's terrible grammar, and I don't care, because my head is full of the want of cheese puffs. That should be a not R. But yes, as you can see, if you compare this, right, what the heck? But if you compare this to .217, you can see clearly like how this works. Like, or again, even .216, which is a little bit better. Like, if you compare it to .216, you can see how, like, P implies Q implies P implies Q implies not Q implies not P. You get the idea. So if it's through transp 216 in particular, you can see how Q implies not R implies P implies not R. Could be like not P implies not R implies not Q implies not R. Do you get the idea? It's the same thing here. Like P implies Q implies not Q implies not P. Right? Because again, I can't stress this enough. P implies Q is not P or Q. Right? And then this is Q or not P. Right? And that would mean that the left for an implication is, I mean, to type this all out, because again, I find it very important. So, P implies Q implies not Q implies not P, right? Now let's undo the first one. So that turns into not P or Q implies not Q implies not P. Now let's undo the next one. So that's not P or Q, or I hit the wrong button. Hold on one moment. Not P or Q implies Q or not P, right? So that's us. We're undoing each implication symbol, right? And finally, to undo the last implication symbol, right? What you're left with is not P or Q or Q. I hit the wrong button. I hope nothing messed up. Q or not P. Okay, I'm pretty sure I did that right. Ah, goodness. Kind of want to make the clickable area as small as possible. Right? So whenever you look at that, that kind of explains the whole implication thing, right? Again, in this, we get rid of the first implication symbol on the left in the antecedent, and then we go down and get rid of the second we deconstruct the second implication symbol on the consequent, and then we deconstruct the primary operator, which is like the primary, like we deconstruct the primary implication, like the primary operator of the expression, which is an implication. So then because right, like if not P or Q implies Q or not P, then the way you get that to be an implication is not P or Q, or Q or not P. You get it? So like it's just kind of branching outwards. Now, I might actually snip that as like its own thing, but the idea here is that, right, this is a way simpler way to look at it, too, by the way. How to put this? I mean, I kind of brought it up already, but you need to remember that not P or Q, right, is an implication. Like, not P or Q means P implies Q, right? And like I said, that's really not blank A or blank B, which turns into not A, or rather blank A implies blank B, right? As I just showed off here. Now, the next thing to remember is, and this isn't necessarily directly important here, but it is something to always keep in mind whenever dealing with implications. And, like, again, the morphology of it, like the whole stack, if you will, of what's going on there, is that I'm pretty sure. Let me make sure, because I know it's in here somewhere. I'm just making absolutely sure because I get the two confused sometimes. Yes, sort of. I mean, it's 211. Right? That is the law of the excluded middle. Right? As said in 211, 2-1 identity is shown as not P or P. So let me just make that clear. Uh, 210. Well, sort of. I don't think it is identity. My bad. That's me being stupid. I misspoke there. I said that because I saw that the proof is identity and star 101. That is not identity. That is me being dumb. Identity is actually... Where is it? I don't think it's called identity. It's like... No. Yeah. Yeah, it is identity. 208. Yeah, wow, actually, that it's... This is kind of a difficult thing to explain. But... Well, not difficult, but... This is why my brain just said, well, that's not. My bad. Yeah, I'm getting them confused. This one is the... Let me back up. Not 212. This is 211. I'm so excited. I'm being an idiot. Law of excluded middle. This is the one that I was thinking of whenever I said it is identity, because I was looking at 210. You can tell by me, like, messing up. But this is the one that I said is identity, and it's technically identity. I don't know why. I guess I was just so flustered that I messed that up, that I wanted to, like, overcorrect. Okay, now that I've calmed down. P or not P is stated to be the law of the excluded middle. Right? And, the demonstration's pretty simple. It's permutation with not P over P, P over Q, which leads to not P or P implies P or not P, which... Yeah. Identity is just P implies P, which is not P or P. Again, I think this is kind of important to keep in mind, all of this, because this is like very basic, very foundational, like, how does stuff work? Stuff. Again, I think I might actually clip this and upload it as its own section, and then maybe stick the rest of the next recording on, and I don't know, name this like Understanding Implication and Disjunction. like a basic version or something. But yes, if I had to, since I guess I will cut this off here before, like, I'll have to do editing later. Right. For me, that's a little scary, but this is very important. Because if you can't, like, in your head understand that every implication is a disjunction, right, and vice versa, some of this stuff just doesn't make sense. Like, it just won't make sense otherwise. Once you can understand that and, like, auto-translate that in your head whenever you need to, or at least, you know, write it down. It doesn't have to be in your head, you know, it doesn't have to be in your head. However you can do it, but if you can do it and then go look at it and go like, ah, okay, I get it now. Like, you need to be able to do that with implications and disjunctions, because one of the trickiest things about disjunctions is that, okay, one of the reasons why kind of need to really drill into your head what each of the basic, like, primitive propositions is talking about is addition, and I'll go into that, I guess, to, like, finish this out. Addition is Q implies P or Q. Okay? Now, what this is about is Q equals Tuesday, right? Q okay, so let's break that down further. Like, to show kind of what I mean by you really need to understand what implication and disjunction are doing in these. So that would also be not Q, or let me even use modern just to, like, the modern negation symbol. Not Q or P or Q, right? So that would mean not Tuesday or let's say that P equals Wednesday. Always say it that way. If I can help it. Yes, Wednesday. P equals Wednesday. Not Tuesday or Tuesday, well, Wednesday or Tuesday. Right? So if it is Tuesday, I don't know why I capitalized at that time. To stay consistent, I will not capitalize it. And also to rebel against modern is that punctuation? Modern grammar decisions on capitalization. That's a dumb joke. I'm not actually, but anyway. So if it is Tuesday, then it's Tuesday or Wednesday or Tuesday. Right. Let me stop because I'm doing the compounding mistake thing. Then it's Wednesday. Is true. Right? But the actual point of add is that you can add a disjunction to a true proposition, and it doesn't affect the truth value. Okay? Now, the reason why that is important is because that is, you can add any disjunction to a true proposition. Right? As they say, Whitehead and Russell say, it is called the principle of addition because it states that if a proposition is true, any alternative may be added without making it false. Because it's true. Like, you could even say not Tuesday or not Tuesday or Tuesday. Because it doesn't change the fact that, right, like, if it is Tuesday, it is still Tuesday or not Tuesday. Does that make sense? Like, one of those things is still true in that disjunction. It's not tying it together. I mean, I covered the conjunction earlier that is, the red and green bug. That if you say, I saw a red and green bug, if it is red, it is false. If it is green, it is false. If it is any other combination of qualities other than red and green, then it is false. This is kind of the inverse of that, where a disjunction allows you to add anything because it doesn't really matter. Like, you could say it is Tuesday or they found what's his name? It's like it is Tuesday or they found Jimmy Hoffa. If it's Tuesday, they don't need to have found Jimmy Hoffa, right? It doesn't matter. Like, you could say it is Tuesday or aliens are invading. It's not an either or. It's not an exclusive or thing. It doesn't like a disjunction. I'm not even sure it would matter, right? With the aliens invading thing, if it was an exclusive or. But my point is that it doesn't matter. Like, if it's Tuesday, it doesn't matter, right? That's the idea. The only way it's false is if both are false. Is if all parts of a disjunction are false. If at least one part of a disjunction is true, the thing is true because, if it's Tuesday or aliens are invading, and aliens aren't invading and it is Tuesday, then the statement is correct, right? That's the idea. So, the reason why that is important is because that kicks open the door to a lot of... Because if you understand how these two things, implication and disjunction, interact, and how they're like almost wow, this is kind of a weird way to put it, but they're almost like it's like a circuit being met. Like, an implication is almost like a circuit flip that disjunction turns into an implication almost. I mean, that's not technically how it works, but like, the idea is that you can look at a disjunction and from it understand an implication and vice versa. And what disjunctions do is allow you to add stuff to, like, right? So you get to see how an implication arises from a disjunction and how you can arrive at a disjunction from an implication. This is very important because it's almost like A side, B side, right, of the same thing. You look at the A side too long, you might forget that the B side exists, and vice versa. And another thing, I guess I'll clip this here, but another thing is permutation, which is P or Q implies Q or P, which write that down. Like, let me type that out. I'll probably clean all this up off screen, but P, crap, or Q implies Q or P. Now, this is permutation, like I said. Now, the idea here is very simple. Is that it is Tuesday or Wednesday implies it is Wednesday or Tuesday. Right? I think this one is self-evident, but bears pointing out that, like, the thing about this that's a little persnickety is that this is symmetrical. Implication isn't. Right? Now, what does that mean? That means you have, like, an almost like a multi-dimensional crowbar where you get to go, okay, through permutation, right? One is not P or Q, and the other one is Q or not P. Now that is actually P implies Q versus not Q implies not P. Very important to remember this. Right? Like, that's what permutation allows for. Like, that principle allows for that. It's for you to basically go, oh, so yeah, alright, you get the idea. Like, that's because, again, implication is not symmetrical directly, but disjunction is. Right? Now, you could say, oh, well, these are symmetrical. And sure, I guess you could say that. But the point is that you can't just go, you can't just say, oh, not P or Q, therefore not Q implies not P. I mean, you kind of can, but if you want to show the demonstrative steps to get there, this is how you do it. This is the mechanism through which you do it. This is the, like, morphological understanding of why you can do that, right? Like, this is the brass tacks, the bare metal, the constituent composition. This is the molten metal. This is the, you know, this is the clay. This is the way that you can do that. And And I mean, you can get to like the associative principle through this. The associative principle is pretty simple. It's P or Q or R implies Q or P or R. Yeah, I mean, that kind of makes sense on its own. And then Q implies R implies P or Q implies P or R, which is sum, the principle of summation, which really is just, I mean, I can see kind of how it's sort of an extension of the same idea of permutation. Like, you can almost look at sum as like, how to put it? I mean, if I were, I could spend, I could very obviously spend a video like talking about all of these. I love this stuff so much. I could talk about all of these, but and I think I've erroneously at one point accidentally said that tautology is the same as identity. No, identity is P implies P, I think. And technically speaking, identity naturally is not P or P, which, you know, but and not P or P, obviously, like P or not P is the law of the excluded middle, so from that you can derive through permutation not P or P, which is through that you can get identity. Yeah, I think I'm going to cut this here, just to, again, make sure that I can have this as its own little video, because I think that was kind of the best concise explanation of how, like, stuff like this, where, again, you have, and the reason why I explained it the other way first, right, the A, B, C, like, A is implying C directly, is because it can be kind of easy to forget that in this, right, where this is A, B, C, it can be easy to forget that it is B and the thing, therefore A implies, you know, the next step, which is the entire point. It's like a compaction of syllogism. I will probably return to um, my older format. Even within this chart, I think I might return to that older format because it's more compact. But I did want to, at least at some point in my graphing series, make it clear in the graphs themselves that what's actually going on is you're establishing the syllogistic causal inference to get to A implies this, right? And just because I'll have this on a video by itself, I do want to get the little not red, not green, red and green bug thing in here. Because again, P and Q is identical to not P or not Q. Right? Conjunction is identical to that. I struggle to understand how I can phrase this, because to say it is a negation of the constituent parts in a disjunctive negation relationship, like an inverse, yeah, it just turns into word soup. You get the idea. It's, again, from here, you get how, like, conjunction is capable of being displayed as a sort of corollary, assuming I'm using that word correctly, and I'm probably not, of, like, conjunction is a corollary of negation, inversion, whatever you want to call it, and disjunction. Right? Again, this is all very, 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 very important for the rest of Principia Mathematica, really, but it's also important just to keep in mind as I go through these parts of the Praeclorum Theorema, assuming I'm pronouncing that correctly, justification table. Because again, I'm basically going to be making the justification tables for every constituent part here. And I may have to expand this image way, way, way out, and I may actually have to just like do some weird thing where I make a composite instead. Looking at just how far back some of these go and just how many moving parts some have, that may be necessary. I hope it's not. I hope I can get them all in one image, but I don't think I can upload anywhere like a 10,000 by 10,000 image. That'd be a little goofy. So I might have to, like I said, make like a series that people can assemble as their own composite if they want. But yeah, again, I gotta shut up. If I'm gonna upload this as its own thing on implication and disjunction and certain stuff, then yeah.